Hello again, and welcome back to the Code Maven programming bootcamp. Hello, Nora.
Hi.
We are going to continue this time what we started at the previous video, and we go over the solutions you have for the exercises in the dictionary chapter. So the floor is yours.
Right. Let me share my screen. You should be able to see it now.
Yes, thank you.
Okay, so the next exercise that we had was the DNA base counter, where we had to print out the content of a DNA sequence in the forms of percentages.
Okay.
So here I asked for the sequence as not in as a file, because that's usually not how you get it, or sometimes in a FASTA file. But anyway, I just asked for the sequence itself from the user. Again, created an empty dictionary and went over the sequence itself. Again, I don't need this list, right? Because it's a string already. So it would go over the characters anyway.
Yeah,
right?
so because it's a string, yeah, it goes over the characters, yeah.
So the only thing that I wanted to pay attention to was that everything is in uppercase.
Okay.
So it wouldn't distinguish between small a's and big A's. And then same counter as before. If it's already in the dictionary, then yeah.
Okay.
And then the interesting part here was this for me. So the formatting of the actual print statement. So here I just made sure that everything that I print out is with 2 decimal places maximum.
Okay.
Or actually 2 decimal places either way. And then from the right, it's 5 characters away.
Yeah, so you have...
So everything is aligned.
Yes.
And then obviously here I just printed the key itself, which, okay, so this is your preference if I'm right.
Yeah.
So I printed out the keys, which were the bases, then printed out the value to the keys, which was the number of times they occurred, and then printed out this bit, which is how to calculate the percentage. Here I used the length of the sequence as a reference to all of them.
Okay. When will this program work incorrectly?
Incorrectly. Not sure.
There's one case I know that this program will break.
Okay, if there is no sequence typed in.
Exactly. Yeah.
Right.
It's a very extreme case, I know. And,
yeah.
And that's actually one of the things that, like, if you assume that the user will use it, won't do this extreme thing, then it's okay. Just you don't have to care about it. If you are more worried and that the user might give you an empty sequence because maybe this is actually going over a file, and there might, so it all depends how much you want to make it user proof.
Right.
And then you could actually check whether there is anything in there and use that.
Right.
Okay. So it's just.
But other than that.
No, perfect.
Okay. Shall we go on to the next one?
Yeah, go on to the next.
Right. Next one was the amino acid counter. Now with this one, I realized when I already made the script that I probably made a bit of a, like I butchered the point of the whole thing of using dictionaries, because my solution was to put the column table like this instead of putting the actual sequences as keys and the names of the amino acids as the values.
Okay.
This was just so much quicker for me to type in, because I wouldn't have to type in the names of the amino acids twice or 3 times or 6 times.
Okay.
But yeah, so I created this dictionary to help with the decoding of the sequence. And then again, I asked for the sequence from the user and already made it uppercase, because all of my codons here were uppercase as well. And then went over like this bit. Obviously, I went over all of the sequence, just taking every like 3 characters.
Okay.
And then appending them to a list, which I called amino acids.
Mm-hmm.
So now I had all of the amino acids separated in this list. And then I had to do this bit because I used the while loop. This statement here would make the sequence, take the first 3 letters of the sequence, and then
Yes.
assign it back to each to the same variable.
Except the first, everything except the first 3.
Except the first 3, yes. And this would mean that after there is no more sequence, after I'm done with all of the amino acids, this statement would become false because it's an empty string.
Okay.
And then I iterated over all of the amino acids, these strings in this list. And I checked if the length of that particular amino acid was 3 or less. And if it's less than 3, then I would just print out that these are remaining bases that don't count for any amino acid.
So I'm not sure that I understand, how could this happen?
So this could happen if obviously a DNA sequence could be any length. It doesn't have to be divisible by 3. So it could be any length. And then if you end up actually putting in, say, an open reading frame, which actually codes for amino acids, but you also take in other stuff from the sequence, which is outside of this open reading frame, then those bits don't actually count for amino acids, don't code for amino acids, and that could be just extra. This is just the biology part anyway.
Right.
And
so I didn't understand the biology part, but
right.
but the code part. So you're taking out 3 characters every time.
Yes, but at the very end of the string, if it's not divisible by 3, there could be 1 or 2 characters left.
Okay.
And I want to catch those characters.
Okay. And you say that Python doesn't care when you're trying to access the first 3.
I assumed I did. I don't know, but I thought that I actually checked this later, and it was true. So when I was going through 3s, right, it takes the first 3, but when there is only like 2 characters left at the very end, it takes those 2 characters and puts it in a string anyway. So it doesn't raise an exception.
Okay, so neither 32 nor 33 is a problematic for that.
No. Yeah.
Okay, good. I wasn't sure about that. Okay.
So yeah, and
so
I just catch that. Yeah, I just catch that and just say, okay, the remaining stuff is not an amino acid.
Okay.
And then for the rest, I iterated over all of the keys in the codon table, which were the names of the amino acids, and I say if the amino acid that I'm currently looking at from here, if the amino acid is in the list that is the key, that is that belongs to the key, then I also have to do this counting thing that we did in the previous exercises. And then one thing that I did, it was not necessary, but I did it anyway, was to append the amino acid into a list called protein sequence, just to have that as a reference at the end. And then if that happens, then I just break out of the loop and start again with the next amino acid. And at the end, I printed out the protein sequence, which was just joining up the list of amino acids, which would end up being the protein sequence. And for the rest, I ordered this counter dictionary and printed out again the same bit as as before, as
Yeah.
we used in
Okay.
the DNA bases.
Okay. So, okay. Any other things here you wanted to say?
No,
No.
this was it for this one.
So K, so the K variable in line 38, what does it have?
Yeah,
What is it? Is a codon inside, or it's an
it's
amino
it's the
acid?
name. It's the name of the amino acid.
Okay. So I would probably put there actually that as a variable, not
Okay.
K. Not, I mean, the technically for the programmer is just a key. So a
Yeah.
variable K is sort of okay, but for the actually for the biologists, it has a meaning.
Yeah. The only thing why I used it as K because I used amino acid before
Yeah. So
to iterate over each of the amino acids in the actual sequence.
yeah, I'm just suggesting that maybe also
This could
AA
be
might. I mean, AA might be also good, but you might also want to replace that with just again. This is something that I suggest that you return to your code later on and then see. Okay, do I like it or do I prefer other names?
right.
Because
So
that's I think that's the way at the end to understand whether it's good for you or not. If it's
I
the
think this makes it more readable, I suppose.
okay, okay.
I could just search and replace, I know.
Well, it would be yeah, okay. So, but then you have to. There are other places with K in
Oh
line
yeah,
50.
one more, yes.
Another one, yeah, and then the format has another one.
Okay.
Yeah. So yeah, okay. Right. So you mentioned at the beginning that oh, you might have not done it the right way because now
It takes
the
more time.
because you did it the way that's easier for you to write down the table, that mapping, but it's not so easy for the computer.
Yes,
It's fine, but now you say that it takes a long time, or it could take a long time if
it
it was a
could.
huge string. And I assume that you might run this code on tons of sequences. So it's a long process. So what maybe you need to do is to take that. So I totally think that that's the right way you represented the data. But then what I would probably do is the first thing I do in the script is convert that automatically into the other data structure. So the mapping from the whatever those source sequences are, so the codons, right, to
Yeah,
the names, right, the amino acids basically, right, to the name. So,
right.
so you can
But so
create a short loop or two, I say, maybe at the beginning of the program, just after you created the variable, to convert it. So in the
right,
program, you typed in, and it will happen every time you run the program. That's true, but it will happen only once, and then when you do the analysis, which might happen a lot of times in the same running of the program, it will be much faster then, because now you have a lookup table.
right.
Okay, so
Okay.
that's just one way to improve. If you and yeah, and I do this quite often because and sometimes you actually need both mappings in your when you're running. So I wouldn't keep both mappings written because that's just a source of a lot of errors. Because in
Yeah.
one I mean, this doesn't this table doesn't get updated too often, I guess. But
No.
but other places it might get updated, and then you
Right.
update one of them and forget the other one, and then problems. Okay,
Yes.
good. So if you don't have any other questions here, then or any
No, it was just this that I realized later that because dictionaries are like one way, this makes it a lot like slower to iterate over all of the
yeah, yeah.
keys.
Yeah.
But anyway.
So I would even probably, because that's just how I do, I would even during this conversion, I would even check whether I had two amino acids, the same as amino acid twice in
Right.
the table, so I didn't make a mistake when I
Right.
was
Yeah.
writing. So it's just because it's just some handling. And finally, I'm almost sure that there is some module in Python in the libraries that already has this table.
Yeah, I'm sure of it, but
Okay,
yeah,
so
I just typed it in anyway.
okay, enjoy.
No, I did not.
Okay.
It's very tedious. Okay, next exercise.
Yeah.
Okay. So the next one was where we had to create a list of dictionaries with the names of the Monty Pythons from a file. So I again prompted the user to enter the path to the file to get the file name, and created the list that I wanted to put the dictionaries in.
Okay.
Opened the file, and then here was something that I had to research because I didn't know how to do. Was the first line of the file was the names of the columns that we would use as keys.
Yeah.
So I didn't know how to get just that first bit. So I researched, and I saw that readline, this method readline, would only read the first line in. So I used that, removed the new line at the end of that, and split it because it was a CSV file. So obviously values divided by commas. So
Okay.
I split using the commas, and then I named that list that was created by this keys, which I would use later. And then for the rest, I iterated over all of the lines and named each line, again, split each line using the comma and named that list values. And then to the list of the original list, which I called people, I appended dictionaries of the key value pairs, each
Right.
with their own index. Now here I actually had a question because logically in my mind I read the first line, but then when I did in the fifth line, I read the first line of the file, but when I did this for line in file in line 6, I would still go over the first line and then the rest, which was not what happened, but I thought that would happen. So what I did was to use this method, read lines, and then added from the first, do the rest. And then I thought, okay, that would be the way to do this. But then even the first line of names and dates of birth was not there. So it left out the first line of values. So I just ended up doing the same thing as before. But I don't understand why.
But it works now, right? So it doesn't include
now it works. Now it works, yes.
But was it the time when it didn't work? I didn't understand.
So when I did, I used this method for line in file handle dot read lines from 1 to the end. Then it left out the first line of name and date of birth.
Okay. Sure. I understand. Okay, so right. So when Python, but it actually doesn't matter what language, but Python opens a file, it has this file pointer, something that points to the location of where we are in the file. And when you read from the file, doesn't matter in which method you read, this pointer moves ahead. So when you read again, it starts from that point.
Right.
So when you called the readline method the first time, it went ahead and read until it found a new line. Okay. So, and then this pointer was there. So when you start now for line in file handler, it already starts from reading from this point.
Right.
Okay. So that's why it doesn't read the header line again.
Right.
When you use read lines from 1 to on, that too, actually the read lines part was reading from that point already. So the read
Right.
lines didn't read the original, the first line, because you already read it separately. So the read lines were read all the lines in that had people in there already. So the second line and on. So when you also set it from one to more, from one to the end, then actually you skip the first one.
Yes.
The first first data line already.
Yes.
Okay. So
Okay.
so this is right.
Yeah, but the rest was kind of clear. And then obviously this was just a print statement that in the exercise you wrote as a test whether the whole thing works. And then for the rest, I just printed out all of it, actually, just saying that that person was born in date of birth.
Okay, good. Can we take a look at the slides and see if in my solutions, because I don't remember if I have this solution or not.
Which was no, you don't. I don't think so. The last one you have was the amino acid one.
Okay, I don't have the solution for this exercise.
No.
Okay, so let's search for something in Google because I would like to show you. So CSV Python, just say CSV Python. So you can click on the first link, it doesn't really matter. There is a module called CSV that comes with Python that can do all this reading and creating the dictionaries and all these things in itself. And in general, that's much better to use because your program now, and well, I didn't teach this yet, and that's just, I'm pointing out now. So your solution, and this is sort of what I usually teach as the first solution of using splitting, but this is what I also now call a naive solution, because this assumes that you only have really commas between the fields.
Yes.
But I can easily imagine data that has fields that internally it has a comma, and then the standard way in CSV is to put quotes around the value. And then the CSV, in the idea behind the CSV is that when it's inside a quote, then the comma doesn't have it's not meaningful, it's part of the data. But this solution with the split, and this doesn't know about it. It just would care about the commas. On the other hand, the module CSV understands deeply what a CSV file is, and you can easily configure whether it's a CSV file separated with actually commas or with semicolons or with whatever other characters. Sometimes people use these vertical line, the pipeline character, sometimes tabs to separate them, and then all kind of like, surprisingly, there are like 6 or 7 attributes for a CSV file that can behave differently. I mean, I can only think about like the separator basically, but there are apparently more. And more styles of how to write CSV files. Anyway, this library is the recommended one then to use. Okay.
Right.
But let's not get into that now. But I wrote it down for myself at least to write a solution that I can show later on, and that you can see. Okay.
Right.
Let's go on to the next exercise.
All right. Next exercise was very similar. It was the Dictionary of Dictionaries, or Dictionary of People, as I called it here, which was mainly the same. Again, I opened the file, created a list of keys, and created a list of values from each line again.
Yeah, so the first part is okay, just the line 8 is different, right?
Yeah, the line 8 is the only difference, where I said that we had to use the tuples as the keys. So this was the first tuple in the dictionary called people, which was the first value, which was the first one of the values, which was the family, no, first name, and then second one was the last name. That was a tuple, and then obviously just enter the dictionary same as before.
Okay, so a comment here, even though, I mean, if you're using the CSV module, then it contradicts my comment now, but and because then you don't need it. But if you're using this way and splitting up, then probably I wouldn't use a variable called values, but instead of that, I would use a 3 variable names, F name, comma, L name, or whatever, so that they're gonna be meaningful. And you don't have to remember, oh, it's element 0 was first name and second name and or family name or whatever, last name.
And date of birth.
Yeah, and then you can use all these things instead of value 0, and that's gonna be much clearer for the reader.
So this was first name and last name. And then again, first name, last name.
Yeah. Of course, this again contradicts slightly the flexibility of the CSV file and the idea that we can move around the columns, because the title, the first line, actually tells us what is in the column.
Yeah.
Okay, now we sort of assume that we understand it and that the order is fixed. Okay, so trade-offs.
Right. Next one?
Yeah.
That will be the last one, which was the legal drinking age exercise. This was, again, interesting because I did the dictionary again the other way than you would expect.
And you filled the whole thing. Oh, I'll need a copy of this. Oh, yeah.
Actually, not the whole thing, because I left out the number 18 because that's the most common. So I entered everything else, and if something wasn't in here, then that was number 18. Now here again, I had something like 0, which was the no restriction.
Wow, there are countries without restriction.
Yes, these bits, these ones. I'm interesting, very informative, isn't it?
Yeah, so I just picked up this exercise because I don't know, it's just a random exercise. And then when I looked at the Wikipedia page about the data, I was surprised that there are countries with 16 and 15 being the limited age. And now you're telling me there is also 0? Wow.
Yes, and well, obviously there are some countries, mostly Muslim countries, where there is a prohibition, so you can't drink at any age. I just used 200 because I don't think there is anyone older than that. So, yeah,
yeah, in general, that's a very interesting question, by the way. How do we represent an upper limit to some numbers?
Yeah.
Because, I mean, in this case, you can quite safely assume that no one lives.
That no one's, yes. Yeah, maybe in a few hundred years, we're going to have to update this when people start to live forever, but not for now. Anyway, I just had to prompt the user to tell me their age and their location. And then again, this is where this dictionary becomes where this script becomes slow, that I iterated over the keys in this legal drinking age dictionary that I created before. And then if the country that they typed in is in the list of one of the keys, then it just this was just for me to sort of debug. I just wanted to see that it actually found the right age. Then it prints out the age limit, and then if the age that they entered is higher than that key or equal to that key, then I exit saying you're allowed to drink, and then if it's not, then obviously exit saying you're not allowed to drink. And then this bit was the extra, which I had to add because of 18. So this extra bit is just I had to repeat myself once.
Yes.
Because, and that's why I used exit here, so that this bit would only run
Yes.
if the for loop went on without any
Yeah,
result.
that's going to be a good exercise to rewrite as a function.
Right.
Okay. Good. Um, there was something I wanted to mention, but I forgot now. Right. Okay. Yeah. Anything else you would like to say here?
No.
Okay. So now I remember that this issue with the limit of 200, and then you said that, okay, we'll have to update it when we, whatever, reach that point. And this certainly reminds me of something that I wonder if you know about the bug 2000.
No.
If you've ever heard about bug 2000, no? Y2K bug, also known as Y2K.
I think
Okay.
I heard the name, but I have no clue what it is.
So there was a huge fear when we came up to the year 2000 that most of the computer systems will just break. And the reason was, and I think it was totally justified, by the way, the fear. So a huge amount of investment went into it in the 10 years preceding the line 2000 to fix the systems. And I even after the year 2000, I see places with this bug, but apparently those were none of them were really critical issues. So we didn't hear a lot of noise that the stuff broke. The thing was that back in the 60s, 70s, 80s, whatever, we really had really little space in the computers, both in the memory of the computer and hard disk or whatever storage we have. It was super expensive and we didn't have a lot of place. And so when people were supposed to write dates, they decided, in 1990, let's say 87, they said, okay, so it's okay to write 87. I mean, everyone knows
Right.
it's 87, and so it was fine, because I mean those years 87 was clear, that's 1987. Okay.
Yeah.
But then we reached the year 2000, and suddenly you would have to represent 00. Now, it still would be sort of clear for most of the people reading it that 00 here means 2000 and 01 means 2001. But if you compare the two dates, then 0 is less than 87.
Yes.
And suddenly all kind of things that assume that compare the dates will suddenly break because work incorrectly, let's say. Okay. And there were lots of issues with this because, I mean, all kind of systems suddenly can think that, okay, we are back in the past 100 years ago, or we are, it can cause a lot of mess. And all this because we and I'm saying it like in general terms, programmers had to or were decided to save those two digits, two characters, yeah, or to some space. So this is one of the issues, and I'm not saying that it's directly related to it. I just reminded me that people were sort of aware of it at one point, but they also said, well, it's a long time from now. We don't have to deal with this because it's just. And then when they got to the, and they also, I mean, in the 70s, not even the 80s, at the beginning of the 80s, people didn't think too much about having so many computers. Well, in the 80s, we already had home PCs and so on. So we had already a lot of computers, but very far from what we had in 2000 and especially now. Okay, so that's one of the things. And it was sort of fixed, and just like at the beginning of this year, people were talking about it because now it was 20 years after, and many people, and in many newspapers, people were pointing out, well, oh, there was all this noise and nothing happened. So there you didn't have, and that's a really strange thing because nothing happened because of all the noise and because of all the investment that went into fixing these problems. And we actually have another problem coming up in 2038, because if you each computer has a clock in it, and in that clock it represents the number of seconds that have passed since what we call the epoch of, I normally just say since the beginning of the times, but the beginning of the times meaning for the computer, okay? And that was arbitrarily decided to be January the 1st, 19,070. And
right.
so this number, and that's sort of fine. It makes difficulties to represent dates before that, but sort of we could.
You mean 1970?
1970, right? Sorry, 1970. Yeah, I don't know. 1970, January 1st. So it was, we have difficulties to represent dates before that, but sort of that's the smaller problem. The bigger problem is that you remember the bits that the computer 32-bit and 64-bit. So because many computers still use 32-bit, and this number is in the 32-bit, as we increase the number, at one point we reach the maximum number that you can hold in 32-bit. And when that happens, then what we call an overflow happens. So when you add a number it's already filled, that's unlike a bath, right? When you add some more water to the bath, it just spills over.
Yeah.
The bath is still full. But in this case, when you add the one more to a number, just think about the binary number, then it gets 0. It becomes 0 because the one bit is supposed to go over for the next
right.
bit. So when we reach with the counting of the seconds, when the 32-bit fills up, then the next second it's gonna be 0. And the 32-bit places to hold this time will reach its maximum in 2038, or I don't remember exactly the second. And if we still have that by then computers running 32-bit, and I'm not talking about your home computer, which you can switch relatively easily, and it will die in a couple of years anyway, so you'll switch to newer. But there are lots of devices that are really old, and they're still using old systems. And they will have to deal with this. Otherwise, they will start thinking that they are back to 1970.
Right.
Okay.
That's interesting.
Yeah, that's, well, it's both interesting and in a way scary, because we really don't know where these systems are, or I mean, I don't know. I mean, hopefully people who are responsible to systems, running systems, they know, they hopefully they know and they care. On the other hand,
Hopefully.
maybe they say, well, by that time I won't be around, so I don't care. So yeah. Anyway, do we still have any exercises?
No, this was the last one.
Okay. Okay, any questions here so far with the dictionaries, with any of these?
No, I'll try to figure out how to make the reverse dictionary, and I suppose I'll have some questions then.
Yeah,
but
okay. So
for now,
so these are the two improvements that you can do. One of them is to reverse the dictionaries, and the other one is to use the CSV module for the other solution. That were the issues. Okay, great. So thank you very much. And then in the next video, we are going to go on. I don't remember what chapter, but we're going to go on with more content. So thank you very much, and bye-bye.
Thank you. See ya.